So right now, fossil fuel refiners are paying up to 25 cents a gallon. And that's not for crude oil or, refining equipment.
Right. It's literally for a government-mandated piece of paper.
Exactly. And today, we're looking at the invisible forces that are fundamentally rewiring the global energy grid. We're welcoming you to today's deep dive. Our mission here is to take this massive stack of source notes tracking the transition to clean energy and basically extract the most crucial aha moments for you.
Yeah, and it's a wildly complex landscape to navigate,
Yeah.
especially because you have all these massive entrenched industries being forced to pivot all at the exact same time.
They really are. And here's our roadmap for today. We're going to move from sweeping government policy mandates to the heavy transport sectors that are desperate for new fuels. Then we'll get into the geopolitical race for hydrogen infrastructure. And finally, look at the ambitious tech trying to just vacuum carbon right out of the sky.
It's a huge journey.
It is. But before we get into the weeds, I do want to add a quick neutrality disclaimer. Because we're tracking how government policies force market economics to shift, we are going to be discussing some politically charged mandates, specifically from the Trump administration's EPA.
Right.
So to be incredibly clear with you, our listener, we are not taking any political sides here. We're just impartially reporting the factual content, the numbers, and the market impacts exactly as they appear in the original source material.
Which, honestly, is the only way to really understand how the machine works. You have to look at the math, not the rhetoric.
Exactly. So let's start right there with the stick of policy, because the math right now is pointing toward a forced evolution of the fuel supply. I was looking through the notes on the Trump administration's finalized renewable fuel standards, and the sheer scale is, well, it's staggering. Walk me through it.
Yeah, so the EPA finalized these historic standards for 2026 and 2027. They're setting record-high biofuel blending mandates. To put numbers to it, they're requiring 26.81 billion RINs in 2026. And then that steps up to 27.02 billion in 2027. They're keeping conventional corn ethanol locked in at 15 billion gallons annually.
Okay, 15 billion.
But the real shockwave here is in bio-based diesel. The targets for that see a massive 60% jump compared to 2025 levels.
Wait, let's pause on the vocabulary for a second, because you mentioned RINs, renewable identification numbers. For anyone who tracks energy markets, those are notorious. How do they actually work here?
Think of a RIN as like a compliance currency. When a gallon of renewable fuel is produced, a RIN is attached to it. So refiners and importers of petroleum are legally obligated to blend a certain volume of renewable fuel into their products.
Right.
But if a refiner can't physically blend the biofuels or just chooses not to, they have to buy those RINs on the open market from someone who did.
So it creates a shadow market. You are literally paying your competitors for a certificate to prove you complied.
Precisely. And the new policy tightens the screws on that market. Between 2023 and 2025, there were these things called small refinery exemptions, essentially waivers that let smaller, struggling facilities off the hook.
Oh, okay.
But this new rule takes 70% of those previously waived volumes and allocates them right back into the overarching mandate.
Okay, let's unpack this. The loophole is basically closing. It's like the government is placing a strict, completely non-negotiable diet on the fossil fuel industry, demanding they consume this much bio-based fuel, period.
That's a great way to put it.
And I understand the macroeconomic goal, right?
Right.
The projections show this reducing U.S. dependence on foreign oil by roughly 300,000 barrels per day. But I have to push back here.
Sure.
Refiners are screaming that compliance costs buying those RINs have hit record highs of nearly 25 cents per gallon of gasoline and diesel produced. If compliance costs them 25 cents a gallon, aren't everyday consumers ultimately got to eat that cost at the pump?
Well, what's fascinating here is that you're hitting on the exact friction point of the entire energy transition. There's this brutal tension between the macroeconomic goal of energy independence and the immediate friction of industrial compliance costs.
Right, because policy acts as a blunt instrument.
Exactly. It forces technological adoption even when it hurts financially in the short term. The market wouldn't naturally shift this fast on its own.
Because fossil fuels are just cheaper.
Right. So the mandate artificially tilts the economics. Okay, so that covers land-based transportation,
Yeah.
but moving logically from land to the skies and the seas.
Here's where it gets really interesting. Because in aviation and maritime shipping, traditional batteries and electrification simply cannot work. You can't just plug a cargo ship into a wall.
No, you can't. The batteries would be too heavy. They need chemical fuels.
Right, so let's look at the skies first. In the UK, the government launched a consultation on how sustainable aviation fuel, or SCF, will be treated in the UK emissions trading scheme. I tend to think of SAF as like a software update for an old computer. You get the upgrade without having to rip out the hardware, the actual plane engines.
That's spot on. SF is what we call a drop-in fuel. It blends directly with conventional jet fuel without infrastructure changes. So it's the most viable near-term solution for long-haul flights.
Okay, but then we look at the Cs. And our sources note this maritime milestone out of China. Shanghai Electric just completed the first large-scale biomethanol bunkering for this massive ship, the CMA, CGM, Ozamium. They integrated green power, green hydrogen, and green methanol production. But let me play devil's advocate.
Go ahead.
Is biomethanol actually a scalable global solution, or is this just a boutique, one-off PR win for a single ship?
Well, if we connect this to the bigger picture, it's definitely not just a PR win. Because aviation and maritime need chemical fuels with high energy density, proper market mechanisms are the only way to make the massive infrastructure costs viable.
Market mechanisms like the UK's ETS carbon pricing.
Exactly. And ETS basically puts a mathematical price on polluting. As that price goes up, the astronomically expensive biomethanol suddenly becomes economically competitive for shipping giants.
Oh, wow.
Shanghai Electric proved the supply chain is feasible at scale for net zero targets. The market mechanisms just make it profitable.
Okay, but the biomethanol used in that ship requires green hydrogen to produce, which leads directly to the next question. Who is actually building the vast green hydrogen infrastructure required to make all this possible?
And that is where the geopolitics come in.
Right, because hydrogen is basically the new oil powering the green revolution.
It really is, and the approaches are wildly different. Let's look at the UK first. Uniper just got approval for the Humber H2 Hub. It's a 120-megawatt green hydrogen facility designed to produce 17,000 tons by 2029.
And they're strategically using existing industrial bases and offshore wind, right?
Exactly, highly localized. Similarly, in France, you have Technip Energies acquiring a stake in a green hydrogen project, showing how traditional energy service companies are pivoting to leverage their old-school engineering capabilities in the new economy.
So that's the European localized approach.
Yeah.
But then you look at China, and the contrast is striking.
It really is.
You have the Chinese manufacturer Sungrow Hydrogen. They just shipped flexible green hydrogen systems to 3 different continents: Oman, Italy, and Brazil. It's this aggressive multi-continent export strategy. So what does this all mean?
This raises an important question for Western markets. It's the ultimate strategic dilemma. You have this tension between accelerating decarbonization using cheap, highly competitive Chinese electrolyzers
Versus the risk of creating a new technology dependence on a foreign power.
Exactly. You need the critical clean energy infrastructure fast, but do you buy it from abroad and shift your vulnerability from the oil well to the electrolyzer factory?
That is a terrifying tightrope for policymakers.
Yeah. It's the harsh reality of global supply chains right now.
Well, let's look at the final defense here.
Yeah.
Because even with biofuels and SF and a booming hydrogen backbone, heavy industries like cement manufacturing still emit carbon chemically.
Right, process emissions.
So what happens to the carbon we simply cannot avoid emitting? We have to catch it or literally vacuum it out of the air? Which brings us to carbon capture.
A critical piece of the puzzle.
In the EU, the European Commission announced 2.7 billion euros for 54 clean industry projects. And this money comes from EU ETS revenues, which is brilliant. A major winner is Holcim, Romania, targeting hard-to-abate cement and lime production with carbon capture.
Catching it right at the smokestack.
Yeah. But then in the U.S., things get more sci-fi. A company called 280 Earth just closed a $50 million Series B funding round, and they are actively operating a direct air capture, or DAS, facility in Oregon.
Pulling CO2 directly from the ambient air.
But I'm going to push back hard on DAS. Isn't direct air capture just an insanely expensive vacuum cleaner for the sky?
I mean, it is highly energy intensive, yes.
Right, so why are investors throwing $50 million at something with such high energy requirements when we could just plant trees?
It's a valid question, but nature alone simply cannot scale fast enough for our current industrial footprints. We don't have the land or the time. The Oregon facility is crucial because it generates real-world data.
So it's not just a lab experiment.
Exactly. It proves to investors that the projected cost reductions over time are actually achievable. It's about building the replicable models today that will save those hard-to-abate sectors tomorrow.
Oh, I see. So if we look at the big picture, it's amazing how interconnected your world is becoming. We've got US biofuel mandates, European carbon pricing, Chinese hydrogen exports, and Oregon carbon vacuums all moving the exact same needle.
They really are. Every piece relies on the others. But it does leave you with a final, lingering question to mull over. As we rapidly build this entirely new, wildly complex global energy system to escape our reliance on fossil fuels, are we simply swapping one global dependency for another? When the dust settles, who will truly control the supply chains of the future?
That is something to think about. Thank you so much for joining us on this deep dive. Keep questioning the world around you, and we'll see you next time.